Okay, so now we are solving sum number 11 from problem set 3 of maths 1 arithmetic progression. Okay, sum is as follows. If first term of an AP is A, second term is B, and the last term is C, then show that sum of all terms is A plus C bracket B plus C minus 2A upon 2 multiplied by bracket B minus A. So this is what we have to prove. Okay. So what information are they giving us? They are telling us that there is an AP. Okay. The AP is the first term of that AP is A, the second term of that AP is B, and the last term of that AP is C. Okay, so this is an AP. Fine. In this AP, we know that term 1 is A, first term is A, term 2 is B. Okay, the last term, that is Tn, is equal to C. Okay, therefore now whenever we solve AP sums, we should know what is the D, what is the common difference. Okay, so the common difference here will be T2 minus T1. So the second term minus the first term, that will be B minus A. Okay, second term minus first term, that is B minus A. So D value is B minus A. Now let us find out the third term. Let us write in terms of the last term, not the third term. So last term formula is Tn is equal to A plus n minus 1 multiplied by D, right? This is the formula for the last term. Now we here know that the last term is C. Okay, so let me write C in place of Tn. C is equal to A is the first term plus n minus 1, and D we have found out here that D is B minus A. So I am putting B minus A in place of that. Okay, now why are we doing all this? Because we want to find out what is n. So we will keep n on the right side and rest of everything will shift on the left. Okay, so first let me write C minus A. So this A, when it goes on the left hand side, it will become minus A. The C minus A is equal to n minus 1 multiplied by B minus A. Okay, now let me put this B minus A also on the left hand side. So here on the right hand side it is in multiplication, on the left hand side it will become division. So C minus A upon B minus A is equal to n minus 1. Okay, now let us put this minus 1 also on the left hand side. Therefore C minus A upon B minus A minus 1 will come on this side and become plus 1. Plus 1 is equal to n. Fine. Now this C minus A upon B minus A plus 1, let us solve this. Okay, so that will give us, now I am just taking this n on the left hand side. Okay, n is equal to C minus A upon B minus A plus, now this 1 I can write as 1 upon 1, is it not? Okay, we can write it as that. Fine. Now this B minus A is the denominator of the first fraction and 1 is the denominator of the second fraction. So they are not like fractions. So we cannot add them directly, we will have to cross multiply, right? So that will give us, therefore n is equal to, in the denominator will multiply b minus a multiplied by 1. Okay, so in the numerator we will cross multiply, so c minus a multiplied by 1 plus 1 multiplied by b minus a. Okay, so what we are doing, we are rationalizing the denominator, right? Therefore n will be equal to 1 multiplied by anything is the same number, so c minus a plus b minus a upon b minus a. Fine. Now in the numerator we can see that we have minus a which we can add, so n value becomes c plus b minus 2a, a minus a will become 2a upon b minus a. Okay, so now see, we have got what is the value of b, we have got what is the value of n, right? So in the sum they are telling us to find out, to show that the sum of all terms means Sn. Okay, we have to find Sn, and we have to show that Sn is equal to this thing. Okay, chalo. So what is the formula for Sn? Formula for Sn is n upon 2 bracket 2a plus n minus 1 d, n minus 1 d. Okay, so therefore Sn will be equal to, now we know that n is what? N is this c plus b minus 2a upon b minus a, right? So we can put in that value. So this upon 2 will become 1 upon 2, and here I am writing the value of n, c plus b minus 2a upon b minus a. Got it? And here in the square bracket we can write 2a, now a cannot be simplified further, plus n minus 1d. Okay, if you look carefully, we had this c minus a plus n minus 1d. Okay, fine. See, tn, let me write it here. Okay, see what we had here, tn is equal to a plus n minus 1d. Okay, therefore now this tn is equal to c is equal to a plus n minus 1d. Okay, so therefore I can write n minus 1 multiplied by d as c minus a, and this minus plus a will go on that side, become minus a, right? So n minus 1d is equal to c minus a, so that I can put it here, n minus 1d, right? So n minus 1d is equal to c minus a, right? So now that will be half multiplied by c plus b minus 2a upon b minus a. Okay, and now this 2a minus a will become a plus c, a plus c. Okay, so now when we multiply all this, okay, therefore Sn will be equal to this numerator and numerator, they will get multiplied, so a plus c bracket c plus b minus 2a bracket closed upon this 2 is in the denominator, so 2 bracket b minus a. Okay, so that is what we have to prove. Fine. So at the end we can write hence proved. Okay, fine. I hope you understood this sum. Let us once again revise this. They are saying that a is the first term, b is the second term, c is the last term. So t1 is a, T2 is B, Tn is C. So we find out B by subtracting the first term from the second term. So T2 minus T1, that is equal to B minus A. Then we write Tn. Okay, so Tn is equal to A plus n minus 1 D. Right? In place of D, we can take B minus A, and in place of Tn, we can take C. So from that, we find what is the value of n. Okay, once we get the value of n, we find out Sn. Okay, and while finding out Sn, we use the value of n as we have found out. We use the value of n minus 1 D. Okay, and then we simplify to get the answer. Okay, so I hope you have understood this sum. Let us solve question number 12 now. In this sum, they are saying that if the sum of first p terms of an AP is equal to sum of first q terms, then show that the sum of its first p plus q terms is equal to 0. And special condition, they are mentioning that p is not equal to q. Okay, so now friends, we know that the sum of first n terms, sum of first n terms of an AP, n terms of an AP is written as Sn is equal to n upon 2 bracket 2a plus n minus 1 bracket close multiplied by d bracket close. Okay, so this is how we write the sum of first n terms of an AP. So in the same way, we can say therefore that sum of first p terms, sum of first p terms of an AP will be written as SP is equal to p upon 2 bracket 2a plus p minus 1 bracket closed multiplied by d square bracket closed. Okay, and sum of first q numbers will be written as q upon 2 square bracket 2a plus q minus 1 bracket closed multiplied by d square bracket closed. Okay, and similarly the sum of first p plus q terms, okay, it will be written like this: sum of p plus q is equal to p plus q upon 2 bracket 2a plus p plus q minus 1 bracket closed multiplied by d square bracket closed. Okay, fine. So we have written the sum of first p terms, the sum of first q terms, and the sum of first p plus q terms. Okay, this we have written. Now according to the given condition, they are saying that SP will be equal to SQ. Okay, SP will be equal to SQ. Okay, that is sum of the first p terms will be equal to the sum of first q terms. Okay, therefore we can write SP we got is p upon 2 bracket 2a plus p minus 1 bracket closed multiplied by d bracket square bracket closed is equal to the sum of q terms, that is q upon 2 bracket 2a plus q minus 1 bracket close multiplied by d square bracket close. Okay, so this is one condition that is given. Okay, and the second condition that is given, which we have to show actually, okay, which we have to show is that the sum of p plus q terms is equal to 0. Okay, so we have to show that s p upon q is equal to 0. Okay, this we have to show. Fine. And this we can write as we have to write that this p upon p plus q upon 2 bracket 2a plus p plus q minus 1 multiplied by d. Okay, we have to show that this is equal to 0. Okay, sum of first p plus q terms, that is p plus q upon 2 bracket 2a plus p plus q minus 1 multiplied by d bracket close equal to 0. So this we have to show is equal to 0. Okay, now when we say that the product, okay, see this multiplied by this is equal to 0, so either this should be 0 or this should be 0. Okay, हे तरी 0 आलं पाहिजे किंवा हे तरी 0 आलं पाहिजे, तर त्यांचं मल्टिप्लिकेशन काय येणार, 0 येणार. Okay, now p is not equal to q. Okay, p is not equal to q, तर हे 0 येणं कठीण आहे because it will be some number, right? p will be some numbers, q will be some number, so I don't think it will come as 0. Okay, ते 0 कधी आलं असतं जर p आणि q इक्वल असते, तर कदाचित ते 0, नाही तरी पण ते 0 आलं नसतं. ओके, सो वी हॅव टू शो दॅट दिस इज इक्वल टू 0. ओके, आता हे 0 दाखवण्यासाठी आपण हा जो ही जी इन्फॉर्मेशन आहे एस पी इज इक्वल टू एस क्यू, ती इन्फॉर्मेशन आपण वापरायची आहे. ठीक आहे, चला आपण ती इन्फॉर्मेशन वापरायला सुरुवात करूया. ओके, चलो. सो व्हॉट डू वी हॅव, वी नो दॅट p upon 2 bracket 2a plus p minus 1 multiplied by d is equal to q upon 2 bracket 2a plus q minus 1 multiplied by d. ओके, तर यामध्ये जे डिनॉमिनेटर मधला हा जो 2 आहे तो कॅन्सल आउट होऊन जाणार. ओके, सो वी हॅव p bracket 2a plus bracket p minus 1 multiplied by d, okay, is equal to q multiply by square bracket आपण टाकूया 2a plus q minus 1 multiplied by d. Okay, so let us simplify this equation now. P, if p we have to multiply by all the terms. Okay, so we will get 2ap plus p minus 1 pd. Okay, p multiplied by d is pd is equal to 2aq plus q multiplied by this will be q minus 1 qd. Okay, this is what we get. Fine, now let us simplify this further. 2ap plus p multiplied by pd will be p square d minus 1 multiplied by pd will be minus pd. So that will be 2aq plus q multiplied by qd will be q square d minus 1 multiplied by qd will be minus qd. Okay, so now can we simplify this further? No. So now let us take whatever is on the right hand side on the left hand side. Okay, so we will get 2ap, मग 2ap सारखा दुसरा टर्म काय आहे 2aq, so I will write minus 2aq plus p square d, तर p square d सारखा इकडे टर्म कोणता आहे q square d, so minus q square d minus pd and this minus qd will become plus qd is equal to 0. Okay, तर काय केलं तुमच्या लक्षात आलं, वॉट एव्हर वॉज देअर ऑन द राइट हँड साइड वी टूक ऑन द लेफ्ट हँड साइड. Okay, now first look at these first two terms. Here 2a is common, so I can take 2a outside and whatever is not common we can write in the bracket p minus q. Okay, असं आपण लिहू शकतो प्लस. ओके, आता या चारही टर्म्स मध्ये काही कॉमन आहे का, तर वी सी दॅट d is common in all these four terms, so let me write it like this: p square मायनस क्यू स्क्वेअर, कारण डी कॉमन आहे तो आपण बाहेर घ्यायचा आहे, मायनस पी प्लस क्यू, and d is common, so I am writing it at the end. Okay, fine. Chalo, now this first term we cannot simplify further, so let it write as it is, plus now here we can see that this p square minus q square we can write as, see, a square minus b square is equal to a plus b minus a multiplied by, let me write it here. We had this formula, a square minus b square is equal to a plus b multiplied by a minus b. Okay, so हा फॉर्म्युला आपण इथे वापरू शकतो. फाइन. So p square minus q square will give us p plus q and p multiplied by p minus q, असं आपण ते लिहू शकतो. बरोबर. आता आपल्याला काय करायचं आहे, सी वी वॉन्ट 1. ओके, इकडे बघा, इथे 1 दिसतो आपल्याला. So this p plus q I can write it as minus 1. minus 1 मी बाहेर घेतला. ओके, या दोघांमध्ये काय कॉमन आहे, तर minus 1 कॉमन आहे. So that will be plus p minus q, okay, is equal to 0. Sorry, not 0. I have to write d first. Okay, d लिहायला मी विसरलो आहे इकडे. Okay, multiplied by d, that is common, right? So d is equal to 0. Now this is correct. Okay, chalo, now 2a multiplied by p minus q plus, now here you can see p minus q is common, so that I can write common as p minus q. Okay, आणि म्हणजे उरलेला आहे p plus q minus 1. Okay, so that entire thing multiplied by d is equal to 0. Okay, now here also we have p minus q and here also we have p minus q. So dividing by p minus q we get, काय मिळतं आपल्याला, जर p minus q ने डिवाइड केलं तर मग इकडे p minus q कट होणार, फक्त राहणार 2a plus here also p minus q will get divided, so we will get p plus q minus 1 multiplied by d is equal to 0. Okay, so see this part, okay, is the same part, right? So we prove that that is equal to 0. मग जर हे 0 असेल तर therefore sum of first p plus q numbers is equal to p plus q upon 2 multiplied by 0. Okay, multiplied by 0. So therefore sum of first p plus q numbers is equal to 0, because 0 multiplied by any number is 0. Okay, so hence prove, ते आपण प्रूव्ह केलेलं आहे. ओके, सो थोडं किचकट आहे सम, बट आय होप if you watch it again you will understand. Okay,